Alright, so we're going to do angle pair relationships 1.6. This is a pretty important lesson. A lot of examples coming out of here. So this is review, warm-up. You should be able to pause the video and do these yourself. So the midpoint, I always put the midpoint underneath the endpoint that they give us. So I'm going to put the midpoint here. That's going to be 3 and 7. This is a test question. And we want to say what happened to go from the x-coordinate of the endpoint to the x-coordinate of the midpoint. So what happened? We were here, and then we went to the middle. So we went 4 to the right, plus 4. We're at -1, we went to 3, that's plus 4. So now we're at the middle. Now we need to go to the other side, so we have to go plus 4 more. So y would be 3 plus 4 is 7. Okay? And then we look at the y's and we say, okay, what happened with y? We were at an endpoint, we went to the middle, we had to go -2 to get to the middle, so we are going to have to go -2 again. So 7 minus 2 is 5. So y is 7, 5. Alright? So we asked that question a few times. It'll be on the next test, so make sure you're comfortable with that. I think that's the easiest way to do that. Okay. So when I highlight stuff in orange, that means I want to change it. So that's something that I want to take out of the notes. So don't worry about that. We're not going to find the angle here. So segment BD bisects angle ABC. So that's pretty important. Bisects means cut in two. Bicycle, 2 wheels, bisect, cut in two. And it actually means 2 equal parts. So on a drawing of an angle, we put those markings there to show that those 2 angles are equal. So in our class, we have 2 main kinds of equations. Equations where we add stuff together and they equal a total, or equations where 2 things are equal to each other. So since that bisects it, it cuts it in half, those are equal to each other. So that's the question you want to ask yourself. Are they equal to each other, or are they adding up to some total? Now, a big clue is if there's no total, then they're probably equal to each other. So there was no total. It never told us what ABC was. So there's our equation. Usually we have a line for it on there. Now, when you have something squared, usually you want to get everything to one side. I like to keep my x squared term positive. So here we're going to subtract x from both sides. That's going to be -4x. And then subtract 6 from both sides. That's going to be -6. So sometimes those things will factor, but sometimes we have to use the quadratic formula here. So when you think about the factors of 6, we're going to go over factoring later, so this doesn't factor. So we're going to use a quadratic formula. So x equals, you can sing the song, x equals the opposite of b plus or minus the square root of b squared minus 4ac. Notice how I use parentheses around all of those things. All over 2a. Okay, so I use parentheses when I'm substituting in for something. Alright, so now we need to do some work here. So I'm going to start inside the square root here. I helped someone with this the other day. So -4 squared is 16. And now we have 3 things being multiplied here. -4 times 1 times the -6. So a negative times a negative is a positive. And then that's going to be 24. Now we can multiply in any order that we want to. So if it's easier to multiply the first number times, now this is a 1, so it doesn't really matter. But we can multiply any of those numbers together first, and we should be okay. So that is going to be the square root of 40. And you have to do simple radical form. We were working on that before. So we always put the perfect square first, and then the number that's not a perfect square second. And we take the square root of that. That's going to be 2, and root 10 is still going to be there. So here we have the opposite of -4. So the opposite of -4 is +4. And then we have plus or minus 2 root 10 over 2. Now, the way we want to do these is we want to split that up. So it's like the opposite of a common denominator. Common denominator we use to add and subtract fractions. Here we're going to separate that. So this would be 4 over 2 and 2 root 10 over 2. Now most of you probably could have done this step in your head, but since it's our notes, I want to write it out. So that's going to be 2 plus or minus root 10, and we'll just leave it at that. All right. The equation A times the quantity B plus C equals A times B plus A times C is true because of, and that's a property, we may have mentioned that in our notes already, but again, always pause and try to answer stuff yourself before you listen to our answer. So that's the distributive property of equality. Okay. So vertical angles. Vertical angles are two angles whose sides form a pair of opposite rays. So one way to think about vertical angles is like the letter X. Vertical angles like the letter X. All right. So if we look at the definition, a pair of opposite rays, two angles. So there's opposite rays. And then if we have another one go through there, another pair of opposite rays. So these two angles, I guess I could highlight them. So that angle, the pink angles are vertical angles, and the blue angles are vertical angles. Okay, so they're the ones that are opposite of each other. Vertical angles. Those are important. We're going to use those a lot, so make sure you're good at this. Linear pair. So you can see I have highlighted there in the word linear is the word line. Say, oh, the word ear as well, but we don't care about that. So in a linear pair, you have a line pair of adjacent angles whose non-common sides are opposite rays. So you have opposite rays, and then you have two adjacent angles. So that's a linear pair. Two angles that are right next to each other, they share one side, and then their other sides are opposite rays. All right. So right off the bat, they're just saying name all of the linear pairs in this picture. So hopefully you can pause and you can answer that question. But so we like to go in order. So I'm going to start with angle 1, and I'm going to ask myself, is there any other angle with angle 1 that forms a linear pair? So you want to draw a straight line. So here's, because that's your opposite rays, and then here's the common side. So I'm not going to be able to highlight all of them because it'll get pretty messy, but that's from my protractor. So angle 1 and angle 2 form a linear pair. Now we get some students who try to say that there are more, but you have to be careful about that. So I guess I could use green here to show that these were a linear pair. So we already did that blue for that linear pair, so there's another linear pair here, 2 and 3. Okay, so angle 2 and angle 3 are a linear pair as well. So the question also asks us, are there any vertical angles? Now, some students in class normally try to tell us that there's some other linear pairs there, but that's not true. Like 3 and 5, they're not sharing this side. Okay? So angle 3 and 5 are not a linear pair because to be a linear pair, you have to share your other side that's not opposite rays. So it's not enough just to have a line. You have to have that shared side. So 3 and 5 are not a linear pair. 1 and 4 are not a linear pair. Really, it would take all 3 of these angles to fill that in, so that's not going to work. All right, so our last one is vertical angles. Are there any vertical angles? So here you're just looking for a letter X basically. So I'm going to highlight that up there. That kind of forms an X. So angle 1 and angle 3. Now you can't say 2 and 4, 5. It's a pair. That means there's 2. Pair, well, vertical angle, linear pair is 2. Vertical angles is 2 angles. So that's the only one. All right. Again, pause. Try it yourself. In a town, 2 streets intersect to form a 36-degree angle. So try to draw that picture. I'm going to pause it and do that. When I come back, it'll be done. So hopefully you paused and did. So it says they intersect to form a 36-degree angle. So it says find the measure of the other 3 angles. So I would suggest that probably the easiest one would be the vertical angle first, because the vertical angle would be straight across here and it would be the same size, so that would be also 36. Now the other angle, if you think about it, that forms a linear pair, because that's a straight angle right here, 180 degrees, and we have 36. So we're going to take 180 minus 36. In geometry, we subtract from 0 a lot, so you want to make sure that you're borrowing and doing your subtraction properly. We don't want to miss questions because of that. Another thing with angles is we want to make sure we put degrees on there. If you don't have a degree symbol, we will usually take a point off there. Okay? All right, so again, we see an X, so we see these vertical angles, and hopefully we see some linear pairs there as well. So it says solve for X and Y, then find the angle measures. So we need to remember to do that second. But so depending on what you're looking at here, so if you look at the vertical angles, because we could set those equal to each other, that would be nice, but there's an X and a Y. And if I look at this pair, there's an X and a Y. So I'm not really excited about getting 2 variables in my equation. So I'm going to look for another option, and the option I see is that if I look up here, this has an X in it, and this has an X in it. So if I take the 2 that have X's in them, I can put them together in an equation, and hopefully you see what equation that is. That's a linear pair. So our equation could be 5x plus 30 plus 4x plus 15, and that's a linear pair, so that's going to add up to 180. Okay? So, I'm going to combine like terms. I'm going to add those together. That's going to be 9x. I'm going to combine like terms these numbers. That's going to be 45. And I have 180 here. Now, I could divide this whole thing by 9 right now, or I could subtract 45 over and then divide by 9. I think I'm going to divide by 9 right now. So if I divide by 9 right now, divided by 9, or multiplied by 1/9, I like better, but so that's going to be x plus 5 equals 20. And now, because those were all easy to divide by 9, so now if I subtract 5 from both sides, then x equals 15. Alright? Now we could do the same thing down here to find y if we wanted to. Or we could plug in some numbers and see what happens. So if we plug 15 in for x, 4 times 15 is 60, plus 15 is 75. And 180 minus 75 is 105. So we could set these two equal to each other, or we could set these two equal to each other, or we could do another equation down here and add these together and set that equal to 180. So we have a lot of options. So I think what I'll do is add these together, which would be 6y, and the 15s will cancel, and then that's going to be 180. So y equals 30. But the key here is that it said find the angle measures. So we need to plug this stuff back in and solve. Although those are vertical, so I know I don't actually need to plug it in. I could just use the vertical angles. find that. All right. So moving along, we are going to talk about complementary and supplementary angles also. So complementary and supplementary. So complementary are two angles that add up to 90, and supplementary are two angles that add up to 180. So one way to kind of remember that is complementary is the letter C, and we could use that for cents, like 25 cents or 50 cents or 5 cents. Pennies, change, and we can think of the S as a dollar sign and dollars. So most of the time you think of dollars, you'd rather have dollars than cents, money-wise. So dollars are more than cents. Another way to remember it is alphabetical order. So alphabetically, C comes before S, and numerically 90 comes before 180. So you need to memorize those. Another way to remember that is C for corner, a right angle, and supplementary for straight, like a straight line. So that's another way to remember it. Another student said the C can be turned into a 9, and another student said the S could be turned into an 8 as part of 180. So lots of ways to remember that, or you could just memorize it. Would be fine also. Are the angles between the hands of a clock at 11 and a clock at 1 complementary, supplementary, or neither? So if you think about a clock, and at 11 o'clock, that would be over here, and 1 o'clock, that would be over here. So if we think about it, 3 o'clock is 90 degrees. So 1 o'clock, 2 o'clock, 3 o'clock, they're all going to be equal. So 90 divided by 3 is 30. So each one of those is 30. So this is 30 and this is 30. So 30 plus 30 does not equal 90, does not equal 180. So the answer to the question is neither. That's it. All right, so now we have some test questions down here. We have 5 test questions. We want to get used to this. So G is the supplement of H. So what does that mean? If G and H are supplementary, that means G plus H equals 180. And then they tell us that G is equal to 82. Remember, 82 is equal sign. And sometimes I leave off the degrees in my work. You just got to make sure you put it back for the answer. So now this is called a system of equations. We have 2 equations and we can substitute. So we can replace G with this 82 right here. So it's going to be 82 plus H equals 180. So if we subtract 82 from both sides, it's going to be 8, 9. So H is going to be 98 degrees. Okay? So again, really good place to pause and try this yourself. So U is a complement of V. So U plus V equals 90. And U is 73, so we can replace the U with the 73 and subtract 73 from both sides, and V will be 17 degrees. Okay, so now it's going to get a little bit harder. So G and H are supplementary. G plus H equals supplementary means they add up to 180. Now, over here, G is half of H. Let's write that out. G is half of H. So, what we can do is substitute 1/2 of H in for G. Or we could clear the fraction now also. What if we multiplied this whole thing times 2? Then we would get 2g equals h. You could do it either way. So we could have substituted 1/2 h in here for g. But if I do it this way, now I can substitute 2g in for h. So I'm going to have g plus h becomes 2g, which is nice, because then we have 3g, and if we divide by 3, we get that g equals 60. Now, the thing is, they asked us to find h, actually, so I was trying to kind of get rid of that fraction early. Now I got to go do one more step, but it's not a big deal. Supplementary means two angles at 180, so 180 minus 60 is 120. So the answer there is 120. Alright, so pause the video, try this last one. These are test questions. You have to know how to do this. We're going to put it on a test. Pause the video. Okay, so g and h are complementary, so this needs to be a 90. Now, g is 6 less than 7 times h. So 7 times h, and then 6 less than that would be minus 6. So some students make a mistake there and they put 6 minus 7h. It's if you have $6 less than I do, you're going to take my money minus 6. So that's what we're going to do. We're going to plug this in for g. So we're going to have 7h minus 6 plus h equals 90. So combining like terms, we're going to get 8h, and then adding 6 to both sides, we're going to get 96. So we're going to divide both sides by 8. 96 divided by 8, 1, 2. So h equals 12. Now if we go back, they asked us to find the supplement of g. We just found h, but we can use h to find g because h and g are complementary, so 90 minus 12 is going to be 78. So now we know that g is 78. Now the question said, what's the supplement of g? So they're getting pretty tricky here. So the supplement of g, so that means add up to 180. So 180, and the supplement of g is going to be 102. And we give partial credit along the way there. So that wraps up these notes. We may add a couple of examples in another video, but there you go. Hope that was helpful. If you have questions, let us know. Contact us. Come to office hours, email us. That last example gets a little tricky. So